Good day everyone, we are the Group 2 and we are here to present one of the branches of hydrology, the hydrogeology. The word hydrogeology has two significant root words that will tell us the scope or the main area it focuses on hydrology. Hydro is the first root word which means water, and we also already know the meaning of hydrology, which deals with all the waters on earth. Specifically, it deals with water or hydrologic cycle, like all the movement of water in different forms. But now the second root word enters, which is geo, meaning earth or soil of the earth. Hydrogeology deals on the water that moves on the soil of the earth, which is called groundwater. So why hydrogeology is significant? Here I have the distribution of H2O on Earth. 97% of water on Earth is ocean water and only 3% of fresh water. In the distribution of the fresh water, we have here different water categories, and surface water is only less than 1%, which is composed of rivers, swamps, and lakes. We humans use fresh water like in agriculture and public water supply, so we should know the available sources of it. This is where the groundwater will play a role because it is 30% of the fresh water. In history and development, we have Henry Darcy in the 19th century. Henry Darcy was a French scientist who made advances in flow of fluids through porous materials. He conducted experiments which studied the movement of fluids through sand columns. These experiments led to the determination of Darcy's law, which we already learned from our previous discussion. It says that the discharge rate Q is proportional to the gradient in hydraulic head and the hydraulic conductivity, with general formula in the presentation where K is the permeability, Mu is the dynamic viscosity of the fluid, and delta P is the pressure drop. Darcy's work is considered also to be the beginning of quantitative hydrogeology. Now for our second person in history about hydrogeology, we have Oscar Edward Menzer, who was an American scientist who is often called the father of modern groundwater hydrology. He standardized key terms in the field as well as determined principles regarding occurrence, movement, and discharge. He proved that the flow of water obeys Darcy's law. Menzer also highlighted the importance of studying geochemistry of water as well as the impact of high salinity levels in aquifers. Now let's talk about the hydrogeology today. Hydrogeology is sometimes referred to as geohydrology or groundwater hydrology. It deals with how water gets into the ground or the groundwater recharge, how it flows in the subsurface through aquifers, and how groundwater interacts with surrounding soil and rock. Hydrogeologists are the people who study and apply their knowledge to many practical uses. Some of these are to design and construct water wells for drinking water supply, irrigation schemes, and other purposes, to discover how much water is available to sustain water supply so that these do not adversely affect the environment, like by depleting natural base flows of rivers. They also investigate the quality of water to ensure that it is fit for its intended use. When the groundwater is also polluted, they design schemes to try and clean up this pollution. Design construction dewatering schemes and deal with groundwater problems associated with mining. And lastly, they help to harness geothermal energy through groundwater-based heat pumps. Now, other fields related to hydrogeology, we have fault zone hydrogeology. It is a field specifically analyzing hydrogeology in a fault zone. It is the study of how brittly deformed rocks alter fluid flows in different lithological settings. This figure shows how fault zones affect fluid migrations in the cross-section view. In figure A, we can see that the fault zone acts as a barrier that blocks fluid flows across it. Black fluid flows cross in it. In figure B, the fault zone acts as a conduit that allows or facilitates fluid flow across it. Another field is the hydrogeophysics. It is a cross-disciplinary area of research that uses geophysics to determine parameters like characteristics, measurements of limitations or boundaries, and monitor processes for hydrological studies of matters such as water resources, contamination, and ecological studies. The field hydrogeophysics focuses on the characterization of subsurface properties, groundwater flow, and transport processes using a variety of shallow geophysical methods.
Issues in groundwater engineering and hydrogeology. Contamination. Groundwater contamination happens when other fluids seep into the aquifer and mix with existing groundwater. Pesticides, fertilizers, and gasoline are common contaminants of aquifers. These are the sources of groundwater contamination. First is underground storage tanks for chemicals such as gasolines. Pwede mag-leak yung gas kapag nangalawang yung tank, and their contents can contaminate nearby groundwater. Sunod is yung septic tank. It can be used to dispose of waste at a safe rate. If hindi na-maintain properly or hindi maayos yung pagkagawa ng septic tank, pwede mag-leak ito ng mga bacteria and viruses or other chemicals into the surrounding groundwater. Next is yung landfill. Yung mga basurang nababaw sa lupa, minsan yan may harmful chemicals na pwedeng mag-migrate from the garbage into the surrounding groundwater if yung protective base layer niya is na-crack or na-damage. Other chemicals such as road salts and chemicals used on lawns and farms can run off into local reservoir and eventually into aquifers. As water goes through the water cycle, contaminants in the atmosphere can contaminate the water. This water can also make its way into groundwater. Here are some controversies in groundwater. First is fracking. Fracking is the process of drilling down into the earth before a high-pressure water mixture is directed at the rock to release the gas inside. Water, sand, and chemicals are injected into the rock at high pressure, which allows the gas to flow out to the head of the well. Contamination of groundwater due to fracking has long been debated. Since chemicals commonly used in hydraulic fracturing are not tested by government agencies responsible for determining the effects of fracking on groundwater. Laboratories at the United States Environmental Protection Agency or EPA, nahirapan sila ma-determine if yung chemicals na ginagamit in fracking are present in nearby aquifers. And noong 2016, nag-release ng report ang EPA which states that drinking water can be contaminated by fracking. This was a reversal of their previous policies after a $29 million study into the effects of fracking on local drinking water. Next is yung California's groundwater controversy. The state of California has faced numerous controversies regarding the use of groundwater that resulted to lawsuits and settlements. Poor groundwater regulations resulted to contaminations from development projects of fishing companies and human activities, threat to wildlife and the ecosystem that surrounds the natural sources of groundwater. Because of these occurrences, California passed the Sustainable Groundwater Management Act in September 2014 that aims to manage and implement the usage and sustainability of water without causing undesirable results. Next is yung sa Denver Basin. Due to its arid climate, the state of Colorado gets most of its water from underground. Yung arid climate is yung climate which there is an excess of evaporation over precipitation. Because of this, there have been issues regarding groundwater engineering practices. As many as 65,000 people were affected when high levels of PFCs were found in the Whitefield aquifer. Groundwater used in Colorado dates back to before the 20th century. 19 of 19 of Colorado's 63 counties depend mostly on groundwater for supplies and domestic uses. The Colorado Geological Survey has three significant reports on groundwater in the Denver Basin. Una is yung Geology of Upper Cretaceous, Paleocene, and Eocene strata in the southwestern Denver Basin. Next is yung Bedrock Geology, Structure, and Isotopic Maps of the Upper Cretaceous of Paleogene strata between Greeley and Colorado Springs. And last yung cross sections of the freshwater bearing strata of the Denver Basin between Greeley and Colorado Springs.
Next is the new trends in groundwater engineering. Since wells are invented and used for thousands of years, the studies and technology regarding groundwater systems also change as technology progresses. These systems on a large scale began to come into consideration, becoming one of the main focuses of groundwater engineering. Here in the 21st century, new ideas and research keep on advancing, making groundwater conservation its priority. The thematic issue on sustainability and water resources include a wide variety of unique contributions in environmental geology and water-related research and practice. Water that moves from the fall of the earth, which is called groundwater. Hydrogeologists often use topographic maps. Topographic maps show the three-dimensional shape of the landscape by representing equal elevation with lines on a two-dimensional map. They are in essence a type of contour map also used in hydrology and oceanography. Although this can be mathematically derived, most geologists create them by measuring the elevation, which is the position, in the field, or an aerial photo, plotting elevation on a map, and connecting lines of equal elevation. It is much like connecting the dots except that all the same numbers are connected, rather than in sequence. Later, I'll show you some samples of different graphs and maps used in hydrogeology. Right, here is a sample of a topographic map. A book entitled Advances in Sustainable and Environmental Hydrology, Hydrogeology, Hydrochemistry, and Water Resources by Helder Chanin and P.G. Chen. One of the authors stated that the groundwater conceptual models includes ground model, hydrological conceptual model, and numerical model. From site investigations to regional watersheds and or global hydrological systems, based on Earth systems, make a major contribution to the sustainability and management of water resources. The next, we're gonna show you some of those models used in hydrogeology. So, for our first example, here is an example of a contour map. It shows the elevations of these surface features, which allows you to look at a two-dimensional map to visualize the Earth in three dimensions. And another example on my right is a coupled groundwater and surface water flow model. This model is created using a software called GS-Flow, showing hydrologic and hydraulic conductivity values used in groundwater modeling. For our next example, we have the groundwater flow model. This model is produced using another software called Hydroflow, the computer code for simulation of two-phase groundwater flow and heat transport in the temperature range of 0 to 1200 degrees Celsius. And the next one is an example of a numerical model, specifically a GW chart. It is a program creating specialized graphs using in groundwater studies. Shown is a graph of budget components for our MPTB USGS simulation. This advancement in topographical mapping have helped us in giving an even more accurate prediction of the future sustainability of an area and the possible changes that can be made to ensure the ground stability. Simulations with higher accuracy allows us for more complex studies and projects in groundwater engineering. With the advanced radar technology penetrating the ground and pinpointing areas such as the example shown, this has made highly complex and individualized water cycle models possible, which has helped to make groundwater sustainability more applicable to specific situations. That's our opinion.